All right, we are on our dilations packet, pages 7 and 8. So on page 7, all you're doing is you're either finding the scale factor or you are finding the new dimensions of your scale drawing. So this first one, our scale factor is 2/5. So we're going to multiply both these numbers by 2/5. So we're going to have 15 times 2/5 and 35 times 2/5. We will have a new dimensions of something by something. When you have dimensions, you have that times symbol, the X in the middle. It just means by. So 15 times 2/5. Well, I multiply the top. So 15 times 2 is 30. Divided by 5 is 6. 35 times 2 is 70. Divided by 5 is 14. 14, yes. You're going to do the same thing for the next one. So we have 10 times 3.5 and 22 times 3.5. Something by something. Last one, you have 9 times 5/3, and you have 30 times 5/3. Next set of these, what is the scale factor? Well, you have original, you have your new one. Remember, new is with the prime notation. And to find out your scale factor, you have new divided by original. And you have to do the same side. So I would do 10 and 8. 10 divided by 8. What does it equal? That would be your scale factor. Again, we have our original. You have your new. To find it, you do new divided by original. 6. The squares shown below represent a dilation performance during the design process of a bathroom remodel, where tile A was dilated to the size of A prime, and Mara believes the scale factor used was 7/4. Explain why the scale factor Mara found would not be reasonable. Okay, so she is incorrect, and then you need to say why. So Mara's scale factor, I'm going to do SF, is not reasonable because, whoops, I spelled it wrong. And then why? And then what is her scale factor? So we have our original, we have our new divided by original. What is the scale factor? Next, Jess is designing a custom rug for a client. The current design is a rectangle with a width of 8 feet and a length of 5 feet. The client wants the rug to be larger but doesn't want the width to exceed 12 feet. Circle any of the scale factors that Jess could use to dilate the current dimensions and meet the customer's request. Okay, so we are currently 8 by 5 and does not want the width to exceed 12 feet. Well, if I do 8 times 2, that's 16. So that means all of our scale factors have to be less than 2. Scale factor is less than 2. So which ones of these are less than 2? There's more than 1. And it wants it bigger, so that means it has to be greater than 1. The next page. So for this one, what you're going to do is you're going to solve each one, and you're going to draw an arrow of where you go. So for this one, A, find the scale factor used in the dilation below. We have original, we have new divided by original. So our scale factor is going to be a fraction. Let me see if I can make this smaller. They're both divisible by 3. So 5 over 2. These are the same fractions. They're equivalent to each other. So A would then go down here. Okay. The figure will be dilated by a scale factor of 2/10. Find the new width. Well, my width is currently 15. So 15 times 2/10, I'm going to write it as a fraction. So I can multiply it quicker in my head. You can keep the decimal. 15 times 2 is 30. 30 divided by 10 is 3. Okay, so this one is 3. So then you're going to go this way. And you're going to solve each of them. Make sure you have the answer in your box. Whoops, sorry. Solve each of them. That is it for this group, so you will need to do the rest of this on your own.